Namaste friends, welcome back to this edition of my show. In this video, we shall see whether a zero bill for our common electricity charges is possible after installing our rooftop solar power generation system. Well, as we know, theoretically it is possible, but what is the reality on the ground? Let us explore that. As we all know, we have 3 meters for our common areas. One is for building A, and as you can see, the bill states solar net meter 13 kilowatts. Then we have another one for building B, and the bill states solar meter 12 kilowatts. The third one is for our heavy duty pumps for the STP and the water as well as the fire protection pumps. Interestingly, this particular bill does not have that comment or the annotation of solar net metering, but we need to explore further. The February bills indeed show the box for net metering, but for both A building as well as B building, it does not show any data. As you can see, when I zoom in, all columns and rows show zeros only. But that does not occur in the STP fire pump bill, even though it does not mention solar meter specifically. Now what you have on the screen is the latest bill for the STP and the fire pumps. Although we do not find the words net meter, the bill does take into account net metering. Briefly, I'll explain the bill sections. What you can see is this section describes the consumer name. The second part is the billing history, which may be for 6 months or 12 months. In this case, it is for 12 months. Then we have the box which is of greatest interest to us, which shows the solar generation, import, export, and all the other related data. Let us look at them one at a time. If you see the first block, it gives the name of the person who is billed, which is the chairman, Forest Trails Atashri. What you see next is the description of the load, which is fire and STP, and below that is the amount that is to be paid. In this case, we had to pay 10,740 rupees before the 21st of February 2025. And here you see what was the payment made in the previous month, which is 87,550. Here is the second block, which shows our billing history for the previous 12 months. At the bottom, I've just made an additional row and column which describes the average. So as you can see, we have been consuming an average of 2,806 units every month over the past 12 months. And the average bill every month for this particular meter was close to 65,000 rupees per month. One interesting feature of the bill is how the tariff is calculated. The tariff does not stay the same over the course of the day. There is an additional charge or discount for the time of the day when the electricity is consumed. So as you can see, between night 10 o'clock till morning 6 o'clock, the rate is 10 rupees. But it rises to 25 rupees between 6 a.m. to 9 a.m. and from noon 12 o'clock to 6 p.m. Next, at the peak hours between 9 o'clock in the morning to 12 noon, the rate drops to 15. And once again in the night, when you have to use electricity for lighting, it is 25 rupees. And now comes the part which is of greatest interest to us. This is a snapshot of the net metering details. You may have a problem reading this in fine print on your mobile screens, so I'll show you a close-up in the next slide. Broadly, there are 3 columns. One for import, another one for export, and finally the column which shows the power generated. Let us now read each one of these columns for different times of the day. As you can see here, that between midnight to 6 in the morning and night 10 o'clock to midnight. This is the time when there is very little sunlight, and therefore you can see here there was very little or no generation, just 2 units, and therefore the export was also 0, whereas we have imported 395 units. The next slot is from morning 6 to morning 9 and from noon until 6 p.m. This is when you have plenty of sunlight. And what you can see over here is true to the reality, which is that we have been able to generate or more than 1700 or exactly 1728 units. But we have exported only 569. And if you see further here under the import column, we have imported 801. We shall examine these figures in the next slide. Then between 9 a.m. to 12 noon, at that time also between these 3 hours, we produced 1267 units, which is the difference between the previous reading and the current reading. And we exported 648 only. At that time, we imported 14 units of electricity. Going further down, you will see that between 6 to 10 in the night, there is again virtually little or no sunlight. And therefore, what was produced was just 5 units. Export was virtually 0, whereas the import was 571. So now you can see that we actually produced 3002 units over the course of the month. But our export was only 1217, around 35% only, whereas our import was 1780 units. So friends, the question arises that why is it that despite producing 3002 units, our export was a pathetic 1217, while our import was 1780 units. The answer to this is found in the circular which was issued by MSEDCL way back in January 2020. And if we were to read paragraph number 7.5 in the next screen, we will come to know why we are suffering this loss. I will now read out aloud the paragraph number 7.5, and it says the renewable energy generating system must have appropriate protection for islanding the RE generating system from the network of MSEDCL to prevent any feeding into the grid in case of failure of supply or grid, and the same shall be verified and certified by the concerned MSEDCL testing division. In other words, whenever there is a power failure, and we have such frequent power failures, especially during sunlight hours, that we are not able to export even though we are producing sufficient electricity efficiently. So friends, the sad news is there is zero export, no export whenever the grid fails. And as we know, we have very frequent outages of supply from the grid. At that time, the rooftop power supply system is of no use. It simply disconnects from the grid. Let us now consider the evidence. What you are seeing on the screen are the plots of the exported units of our STP fire meter over the course of 3 days. These are monitored on an app, and they are a graphic representation and show how export is affected by power failure for almost equal sunlight. If you see the plot on the left hand side, you will find that there's a slight gap in white like a wedge. This is showing the loss in export due to power outage. This is what I'm talking about as pointed by the red arrow. On this particular day, that is 19th of February, the total export was 166 units. On another day, a day earlier rather, on the 18th of February, there is a large gap, and therefore the total output or export has reduced from 166 as shown on the 19th February. It could achieve only 128.5 units. And on the 20th of February, you will find there's a big gap. This was the day when there was a long power outage, and that cost us dearly. As you can see, the total export was merely 46.6 kilowatt hours. And mind you, on these 3 days, the sunlight hours and the intensity of the sun was almost similar. So friends, now let us take a look at the numbers. What we have generated is 3,002 units. But our export is a pathetic 1,217 units. In other words, it's only 41% of our produce which is exported. On the other hand, our import is still 1,780, which means we have been billed for the difference between the two, and that works out to 563 units. Thus, the saving was around 68.37% and not 90 or 100% as we had thought it would be. Going further, we see that if we keep on saving at the same rate, on a bill of 16.5 lakhs, we shall be saving approximately 11 lakhs and 28,000 rupees every year. And our annual bill will work out to 5.22 lakhs or 5 lakhs and 22,000 only. We will now take a look at it from the return on investment point of view. We have invested 25 lakhs, spent 35 lakhs, and we are expecting a subsidy of 10 lakh rupees from the Prime Minister's scheme. If we work out the interest that is lost on 25 lakhs at the rate of 7.5%, it comes to 1,87,500 rupees. Now let us look at the saving which we shall be making on our annual bill of 16.5 lakhs. As we saw in the previous slide, we are saving at the rate of 68%. So our saving will be 11 lakhs 28,000. So the net that will be saved after taking into account the interest lost, we are still at an advantage of gaining 9 lakhs and 40,500 rupees every year, or the first year rather, because gradually our corpus is going to build up every year. Now, if we do simple arithmetic, we will find that the net saved per year at the rate of 9.4 lakhs, the recovery of the entire cost of 25 lakhs will take about 2.5 years only. So friends, is there a way out? Could we possibly find a relief? I think the answer lies in filing a petition with the Prime Minister's office. This can be done online. I'm trying to find out how this is done, and I'll revert back to you once I figure out how this is to be done, so that we can file in multiple petitions on behalf of the society. Because we have already spent 35 lakh rupees, and the government is also going to put in a subsidy of 10 lakh for us. So the stakes are pretty high for two parties, the central government as well as the society. So I'm sure they'll be able to prod MSEDCL to improve their performance. And let's see how it goes. I'm not very sure of how it will work out, but at least we should explore that possibility. Besides sending a petition to the Prime Minister's office, we can also send a petition to the Electricity Ombudsman, which has been created under the Lokpal bill. You can see the email address over here, and essentially we have a very strong case because we are protected by the Consumer Protection Act of 2019, and we are suffering from MSEDCL's deficiency in service. And we can appeal to them for any act which causes a loss to the consumer, and we are losing a great deal of amount. In fact, we can even demand a compensation for the cost of the rooftop solar project. So that's worth another try. I'm exploring that possibility as well, and I shall revert back to you shortly. So friends, that brings me to the end of this video. I shall now summarize the key points. Our rooftop solar plant is generating well, as we have seen from the numbers which were shown in the video earlier. Unfortunately, our export is falling short of our expectations for no fault of ours, and it's entirely the inefficiencies and deficiency in service of MSEDCL. And to overcome that, we have also seen how we can overcome that by petitioning to the Prime Minister's office and to the Electricity Ombudsman or Lokpal. So once again, thank you very much for your attention and for the time that you spared, and we'll meet again in another video. Until then, bye-bye and thank you.